Okay, I'm going to do a little bit more math today. This is going to be way shorter than the previous day's video, and we're going to look at finding an angle with our triangles. So let's get to it. Just as a reminder, what we did yesterday or the previous video, if you've been watching in order, was if we know two sides of a triangle, like the hypotenuse and the adjacent, we can use the Pythagorean theorem to give us our last side by doing the a squared plus b squared equals c squared. So if we know two of those, we can get the last side. We also said if we know an angle and one of the sides, in addition to the 90 degree, which we always know, we can use a trig function, sine, cosine, tangent, to give us the other side that we're trying to find out. And then if we know two sides of a triangle, we could then use the Pythagorean theorem to find the last if we needed to. So these are always helpful. A couple of things right here, but the last thing we want to look at as we move forward and try to start doing some physics is what if we know two sides of the triangle or three, and we want to find the angle that is in there. And that's going to be an important part of what we're working on for the next week to be successful on some things. This is where the inverse function on your calculator comes in, okay? And so these, when I say inverse function, that's the sine, cosine, tangent with the -1 up above it. This is kind of like, flipping the sine or the cosine or the tangent over. It's going in reverse, just like, the opposite of multiplying is dividing, the opposite of dividing is multiplying. These kind of send us in a reverse order. So, excuse me, they look strange, but are kind of easy to use. Now, real quick explanation, nothing to be tested over, but some people like to kind of know what the heck all this stuff means. Just, you may have learned, I know you learned this stuff in math, but who knows how it was explained to you. When you take the sine of the angle, it's basically giving you the ratio of the two sides made by that angle. So we'll give you an example. If you had a 30-degree angle, the sine of a 30-degree angle would be the opposite side divided by the hypotenuse. Now, if you take the sine of 30 degrees, the answer is always 0.5. Doesn't matter if it's a giant triangle, doesn't matter if it's a small triangle. If you have a triangle that has a 30-degree angle in it, the opposite and hypotenuse are going to make a ratio of 0.5. Now, if you think about what 0.5 is, that means it's like 1/2. So the opposite side is always going to be 1/2 the side of the hypotenuse, or the hypotenuse is always going to be twice the size of the opposite. That's what the sign tells us. Okay, so the sign is always about the ratio that's being made, because again, I mentioned this yesterday, when you change angles, you change the links that are having to be made in order for that triangle to still be a triangle. If we use the inverse sign, basically we're going in reverse, which means if we know the ratio, for example, if I've got a triangle and I know that the hypotenuse is twice the opposite side, that's a ratio of 0.5, 1 to 2. And then we know, kind of going in reverse, that the only way you get that angle is to have a 30-degree angle. That's the way the thing works. Once upon a time, people had to look all these up in a book. And this would be a giant book of a whole bunch of values of sines and cosines and tangents and angles and all kinds of things. And now you just get to punch them in on your calculator and it spits it out for us. So that's what the sine and the cosine tangent are doing. That's what the inverse are doing as well. It's just about making ratios and understanding what kind of ratio would turn into sides and what kind of sides would turn into a ratio, and or how the angle fits in. That's just some info. So the important stuff is, do we know how to do this stuff? So we're going to do a couple of examples, and I'll hopefully get you to work some on your own. So if we use this triangle down here below, notice we don't have any angles. We've got two sides that are given to us, and we've got two angles we're trying to find. So we can find X and Y. So again, we'll list everything out. If I want to try to find the angle of X, then I need to use the two sides. So then the 31 is adjacent because it's next to the X, and the 23 is opposite because it's across from it. All right. Once we identify that I've got A and the O, we use a reference sheet that tells us we can use the tangent function. And so tangent is opposite over adjacent. And because we're looking for the angle, remember this always, 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 always. When we're looking for the angle, that's when we use the inverse function. So we're going to put this into our calculator and make it look like this. So we're going to do the inverse tangent and then 23 over 31 because it's still opposite over adjacent. And it's going to give us this little number right here, which is 36.5. And that's our answer. We're done. Just a couple of notes using your Desmos calculator. is that to get to these functions down here, you've got to hit the function button, because when you open it up, these are not going to be there. So hit the function button, and it's going to change it to look like this on your calculator. And you're just going to, click the tangent -1. If we want to define the y, basically we're still doing the same thing, but my ratio gets flipped around. So to find y, I'm still using 23 and 31, but now 31 is opposite and 23 is adjacent. So the math is exactly the same. Make sure you're using the scientific calculator, not the graphing one. And the only thing we end up doing differently is our fraction gets flipped over, because since we're using different angles, the adjacent and the opposite get flipped over as well. And so 31 over 23, that ratio is going to correspond to a 53.4 degree angle. So again, inverse tangent, opposite over adjacent, there's our answer. That's all we got to do. So again, we're just building on what we did previously about identifying the sides of what's what. Example 2, very similar, right? So, but I've got things labeled a little bit differently here. So if we want to find x, all right, so I've got two sides labeled. The 20 is the hypotenuse because it's across from the right angle. 13 is adjacent because it's next to x. So we've got a hypotenuse and adjacent. H and A use the cosine function. Again, we'll use your reference sheet for that. That's our formula, the way that it looks. Since we're finding an angle, I'm going to try to remember that I use the inverse function. So I just do the inverse of cosine. The adjacent side goes on top of the fraction. Hypotenuse goes on the bottom of the fraction. Close it up, and that tells me what my x angle is. Now, you could also do some math, because remember, if you wanted to just at this point figure out what y was, you could say this angle plus 90, and then subtract that from 180, because all the angles have to add up to 180. Or we could just use our inverse stuff to be able to figure out what y is, because if I'm solving for y, I've still got a hypotenuse, but now the 13 becomes opposite. And so I've got h and o instead of h and a. H and O uses the sine function. And so my fraction still looks exactly the same. It's still opposite over hypotenuse. Previously, it was adjacent over hypotenuse, so it's still 13 over 20. But the change we make this time is we're using sine instead of cosine. Okay, so continue trying to use these steps, which is to label all your numbers and your angles about what is what, so that you can figure out which formula to use. And once you know which formula to use, we're just going to plug it into the calculator to get it to work. Okay, I've given you some examples for you to try on your sheet, just to double check you know what you're doing. And once we're able to kind of get these things done, then we've kind of got a good basis of our math to be able to then do some physics problems about things moving around and calculating the angles that we have with that. I will stop recording.